Okay, welcome back. We are going to be now talking about our next set of inferential statistics. We've gone through chi-squared and phi, and we're moving down this matrix into this quadrant of the matrix where the independent variable is categorical. So the values are groups of things, or they're categories of things, meaning they're nominal or ordinally measured, and the dependent variable is interval or ratio. And the t-test is actually a special case of analysis of variance. It's a special case in that the t-test is only looking at an independent variable with two categories only. So an independent variable that we would say is dichotomous. A dichotomous variable only has two categories for values. This is how we spell that. And the dependent variable is measured at the interval ratio level. So essentially what we're looking at is whether or not the means on the dependent variable are different, statistically different, for the two values of the independent variable. That's what we're looking at when we're looking at the t-test. The Cohen's d is simply the effect size for the t-test. With an ANOVA, or the f-test, you can have two or more categories to run that. So for this part, I'll just put greater than two categories. That's an arrow. So let's talk more about the t-test. So the t-test is designed to tell the researcher whether the mean difference between the two groups is statistically significant, or that the difference is big enough that it couldn't possibly be due to coincidence or chance. In terms of a formula for the t statistic, so t-stat stands for the t statistic, you can calculate the t statistic by dividing the difference between the difference of the means by the standard error difference. So we essentially have two categories, and we'll look at some examples here. But let's say we're looking at a variable like, did you attend orientation? And that was a yes, no. And I'm going to abbreviate orientation. Yes, I attended. No, I did not. And we want to look at, let's say, the difference between the means between those who attended orientation and those who did not on some other type of dependent variable. Let's say the dependent variable is number of days before the semester starts that a person registered for classes. This might not be a very good variable because somebody who doesn't attend orientation, maybe they could be a continuing student, but somebody who does attend orientation is probably going to register on that day as well. But let's say the mean is 30 days. So somebody who attends orientation registers on average 30 days before the start of the semester. And somebody who doesn't attend orientation on average registers, let's say, 2 days before the start of the semester. And so this is the mean for this category, and this is the mean for this category. So the mean difference would be simply 30 minus 2, which is 28 in this case, divided by the standard error difference. So the mean of 30 will have a standard error, and the mean of 2 will have a standard error. I don't know what that will be, so let me just tell you that divided by the standard error difference. And that's how the t-statistic is calculated. SPSS is going to do this for us. So let's see what this looks like exactly. This is an example of looking at males and females and looking at their mean scores on the compass placement writing test. So I've run this analysis in SPSS, and here's what the output looks like. We get statistics, regular descriptive statistics for each variable. Compass writing, males, their mean on the compass writing test is 77.6. Compass writing test for females, their mean is 77.25. There's their standard deviation, and here is where SPSS calculates the standard error, which I have been abbreviating like this, standard error. And so the t-statistic is simply calculated as the mean difference minus the mean for the women divided by the standard error difference. .886. So if you wanted to calculate this out, what you would find in the independent samples t-test is this value. The t-statistic was equal to 0.276. What we can see is that this value of t does not turn into a statistically significant result. This is the significance, SIG, and it's a p-value, 0.783. That p-value is much greater than 0.05, and so it's not statistically significant. So you could say, what you would say then is that the mean differences between males and females on the compass placement writing test is not statistically significant. Another way you could look at this data that is provided when you run a t-test analysis is this 95% confidence interval of the difference. And so this is showing you where, or it's showing you the interval for where the mean difference can fall between minus 2.2 and on the upper end 2.96. Well, what's intriguing about this is that if this interval contains a mean difference of 0, then you know that you are not going to have a statistically significant result. And so that's why it's kind of interesting to, and what Voigt recommends is to actually give in your analysis what the confidence interval is. So you can be 95% sure that the mean difference falls within the confidence interval. And if that confidence interval contains 0, like this does, in this range between minus 2.2 and positive 2.9, there's a 0 in there, in that range. That means that a mean difference of 0, if that's a possibility, a mean difference of 0, it means that there's no difference between males and females. And you can be assured that your relationship is not going to prove to be statistically significant. We aren't going to worry yet about some of these other statistics you see in this table, but this is what SPSS will give you. DF stands for degrees of freedom. We're not going to worry about that right now. What you need to worry about is the fact that this is the T statistic, this is the significance level, and this shows you the 95% confidence interval on the right-hand side. In order to calculate the T statistic, up here we did it by hand based on the descriptive statistics, but SPSS can do this for you. Here is the mean difference and the standard error difference calculated for you. This ends this part of the module's presentation. Please move on to review the next part